Welcome to Module 2, Lesson 1. Today we're going to be multiplying whole numbers that involve multiples of 10. And you're going to see how, just by knowing a few things about math, we can make some of these double-digit problems and triple-digit problems mental math. So in my first example, I have 23 times 20. I can rewrite this as 23 ones times 2 tens, and since I have 23 groups of ones, that's the same as multiplying. So really what I have is 23 groups of ones times 2 groups of tens, and my commutative property tells me I can regroup these sort of things, so I could actually just do 23 times 2 and get 46, and ones times tens, that's tens, or an answer of 460. On my next problem here, I have 230 times 20, and the difference being that 0, otherwise we're all the same. I'm going to write a little shorthand here. Instead of writing out the words ones and tens, I'm going to write it in standard form. So I have 23 groups of 10 times 2 groups of 10. And again, I have 23 times 2 is 46. And then I can multiply that times the 10 times 10 is 100. So I have 46 groups of 100, or 46 hundreds, or 4,600. Well, this can be applied to a problem such as this, just to make things a little easier. I mean, this could be a big double trouble kind of problem. I have 7,180 times 20, but I can just make this a little bit simpler by knowing about my place value system and multiplying by powers of 10. So I could just change this to 718 times 2, and then I need to make it 10 100 times bigger. So 10 100 times bigger, just like that. And I get 143,600. Just to review again, I changed this problem to 718 times 2 times 10 times 10. Did this part out by hand, and then I could make things 10 times and then 10 times again larger just by moving my digits to the left of my place value chart. And just understanding how that commutative property works and why we're doing what we're doing, we can avoid a common mistake, and that's illustrated in this problem. Ripley thought he knew a shortcut. He told his mom that multiplying whole numbers by multiples of 10 was easy because you just count the zeros in the factors, and that is the number of zeros in the answer. And he gave this example to prove his point. 7,000 times 600 is 4,200,000, and that is true. So he said, well, there's 3 zeros in the first number and 2 zeros in the second number, so my answer has to have 5 zeros, and indeed it does. But his mom, who's pretty sharp, she says, that doesn't always work. Be careful there, sweetheart. And why not? And give an example where his method yields the wrong answer. Well, here's an example. If he used his method here, he might say 5 times 4 is 20, but my answer needs to have 1, 2, 3 zeros. So he might claim that it's 2,000, and that is absolutely incorrect. The reason why is because if Ripley had been in our lecture, he would have known that he could redo this as 5 times 10 times 4 times 100, and use the commutative property to regroup and get 5 times 4 times 10 times 100, and 5 times 10 is 20, and I can make it 10 times larger by moving things to the left, and then 100 times larger by going 2 more times, and you get an actual answer of 20,000, which has 4 zeros. The reason being that the product of 5 and 4 give us a 0 right there, and then we have to make things still 1,000 times larger. So that's why we need to understand what we're doing here. And that's all there is for today's lesson.